everyone, welcome to our webinar. Do you know why you are here? Of course you do. This webinar discusses different types of chemical reactions, but today we will be telling you something regarding the formation of ozone layers in stratosphere. Did that catch your attention? If yes, then let's start.
But before we start with the main topic, do you even know or understand what ozone layer is?
Ozone layer is a thin part of the Earth's atmosphere that absorbs almost all of the sun's harmful ultraviolet light. It is the common term for the high concentration of ozone that is found in the stratosphere around 15 to 30 kilometers above the Earth's surface. It covers the entire planet and protects life on Earth by absorbing harmful ultraviolet radiation from the sun. Then this is where we introduce the stratospheric ozone. Stratospheric ozone is formed naturally by chemical reactions involving solar ultraviolet radiation and oxygen molecules, which make up 21% of the atmosphere. Earth's stratospheric ozone layer contains about 90% of the ozone in the atmosphere, which makes the planet habitable by absorbing harmful solar ultraviolet radiation before it reaches the planet's surface.
Now, let us know more about the scientists and the processes in it. Scientists have worked to understand the chemistry of the ozone layer since its discovery in the 1920s. In 1930s, a British geophysicist named Sidney Chapman described a process in which strong UV photons photolyze oxygen molecules into highly reactive oxygen atoms.
Ozone and oxygen molecules in the stratosphere absorb ultraviolet light from the sun, providing a shield that prevents this radiation from passing to the Earth's surface.
While both oxygen and ozone layer together absorb 95 to 99.9% of the sun's ultraviolet radiation, only ozone effectively absorbs the most energetic ultraviolet light known as UVC and UVB.
This ultraviolet light can cause biological damage like skin cancer and tissue damage. Oh, and also our important eyes, since it can also reserve vision when we have a long-term exposure to even small amounts of UV light. It may cause eye issues such as cataracts, sunburned eyes, etc. The protective role or protection of the ozone layer in the upper atmosphere is so vital that the scientists believe life on land probably would not have evolved and could not exist today without it.
This atom rapidly combine with O2 to form ozone. This process is still recognized as the only significant source of ozone to the stratosphere. Research and controversy have focused on identifying stratosphere ozone sinks. Now, let's go deeper about ozone.
Ozone is produced by different processes in the stratosphere, where it is beneficial, and near the Earth's surface, in stratosphere, where it is harmful.
The mechanisms for stratospheric ozone formation and photolysis of O2 does not take place in the troposphere because the strong UV photons needed for this photolysis have been totally absorbed by O2 and ozone in the stratosphere.
The ozone in the stratosphere is produced by photochemical reactions involving oxygen. When diatomic oxygen in the stratosphere absorbs ultraviolet radiation with wavelength less than 240 nanometer, it breaks apart into two oxygen atoms.
The resulting oxygen atoms combine with O2 molecules to form ozone. This reaction is exothermic, and the net effect of the previous two reactions is the conversion of 3 molecules of O2 and 2 molecules of ozone with the simultaneous conversion of light energy to heat. Ozone absorbs UV radiation with wavelengths as long as 290 nanometers. This radiation causes the decomposition of O2 molecules and oxygen atoms.
And that's it! We've already explored the topic about ozone. Let's hope we're not out of zone while we tackle this, so we have a better understanding about how important this lesson is. I hope you learned something about it, and have a nice day. See you for our next webinar!